Okay, so we are on the Geometry Unit 10 assessment, which is basically covering trigonometry, special right triangles, and Pythagorean theorem. There's a couple of extra questions in there that are from different sections, but that's the bulk of this section. So let's start with question number one. In question number one here, I have a right triangle. They told me that they show me this is 64 degrees. They told me that the light pole is 45 feet high, and they want to know what is the hypotenuse here. So obviously this is a trig question. The first thing I did was I labeled my hypotenuse, and then I labeled the opposite side of the angle, and this would be the adjacent side here. But when we look at it, well, they gave me the opposite side. That's why I highlighted the O, and they're asking me for the hypotenuse, so I highlighted the H. So out of the three trig functions, that we use so, ka, toa, if I have the letters O and I have the letters H, well then I'm going to use so, which is going to lead me to the sine function, right? So I'm going to take the sine of the 64 degrees, and we know that the sine is the opposite over the hypotenuse. That's what the so in so katoa tells us. So the sine of 64 degrees is equal to the opposite over the hypotenuse. Well, the opposite side is 45. So I put that here, and the hypotenuse is, I don't know, so it's x. So that's why it's 45 over x. Well, now that I've done that, I go into my calculator, I type in the sine of 64 degrees, I get 0.8988, and that's going to be equal to 45 over x. We know that we want to get rid of the denominator, so I multiply across the equal sign. So when I multiply x times 8.8988, I get 0.8988x is equal to 45. I managed to get rid of the x in the denominator, which is why I multiplied across there. Now I want to solve for x. So what do? I divide both sides by 0.8988. These cancel out, and x is equal to 45 divided by 0.8988, which is 50.06. And when you look at your choices, the closest choice to that would be choice B, which is 50 feet. Okay, let's move on to question number two. Question number two says, which set of numbers does not represent the sides of a right triangle? Which one does not? That means that three of these choices do and one of them doesn't. Okay, well, here I have a right triangle that I drew. And you should be familiar with the Pythagorean theorem. You know that a squared plus b squared is going to be equal to c squared. So you know that c is always the longest side of any right triangle, right? So when I look at these numbers here, I know that the biggest number is always going to be the hypotenuse of that right triangle. Well, if these are the sides of a right triangle, then the Pythagorean theorem should equal out. For example, the Pythagorean theorem says that what? A squared plus b squared is equal to what? C squared. So here I got 6 and 10, and 6, 8, and 10, right? Well then, 6 squared plus 8 squared should be equal to 10 squared, right? Well, 6 squared is 36, 8 squared is 64, and 10 squared is 100. Is 36 plus 64 100? The answer is yes. If you add 36 plus 64, it's equal to 100, which means then that these sides represent the sides of a right triangle because the Pythagorean theorem checks out. Let's take a look at choice B. Choice B, I have 8, 15, and 17. Obviously, 17 would be the hypotenuse. So again, I do a squared plus b squared is equal to c squared. Well, that's the a, I could be 8, the b could be 15, and the c is going to be 17. So 8 squared is 64, 15 squared is 225, and 17 squared is 289. Well, when I add 64 plus 225, I do get 289. So again, these sides here are the sides of a right triangle because the Pythagorean theorem checks out. Now when I look at choice C, again, here's my Pythagorean theorem. I do 8 squared plus 24 squared, and I hope that that's equal to 25 squared. Well, 8 squared is 64, and 24 squared is 576. Well, when you add these two together, it doesn't equal 625. Okay, which is why the Pythagorean theorem doesn't work for these numbers, and that's why my answer is C, because the question is asking which does not represent the sides of a right triangle. If you did D, it would also work out too, but I'm not going to waste my time with that because I already found my answer here. And you can see other examples in the first two choices. Okay? Let's move on to question number 3. Question number 3, you have a special right triangle. You know that it's a special right triangle because you have 30, 60, and 90. You know that by looking at your reference sheet, you know that the little leg is usually just x, a number, and the long leg is x times the square root of 3. And I know that this is my hypotenuse, and that's usually 2 times the little leg, or twice x, right? Well, if you look here, the long leg is just 12, right? When you look at your reference sheet, you're accustomed to seeing the square root of 3 next to the long leg. But remember in class we discussed that if the square root of 3 is not there, that means that it's already been factored or multiplied into your side. And we talked about, well, if the square root of 3 is already in there, well, how do I pull it out? Well, if you remember in class, we said that when you have a square root inside of any number and you pull it out, you're going to get this. So for example here, my long leg is 12, right? There's no square root of 3. So we talked about the rules of dividing by a square root, and we said that when you pull out a square root of 3 from 12, you should get 12 times the square root of 3 divided by 3. And then 12 divided by 3 is going to give me 4. So it's going to be 4 times the square root of 3, which is choice C. Let's take a look at question number 4. Question number 4, we have a triangle below, and they want to know what is the cosine of L. So obviously, they want us to focus our attention on angle L right here. Well, the first thing I did was I labeled my right triangle. This is going to be my hypotenuse. If I'm focusing on L, that's going to be the opposite, and this side here is going to be the adjacent. Well, they want to know what the cosine is, right? Well, remember, you have your 3 trig functions, so, ca, and toa. Well, the cosine function tells us that we do what? We take the adjacent side over the hypotenuse. The adjacent over the hypotenuse. That's what the cosine tells me to do. That's why you remember so, ca, toa, because it helps us remember the relationships of the sides. Well, if the cosine tells me that it's the adjacent over the hypotenuse, well, here's my adjacent side, right, which is JL, and I put that at the top there, over my hypotenuse, which is KL, and that goes in the denominator. So JL over KL. Adjacent, JL, over hypotenuse, KL, which is choice D. Let's move on to question number 5. Question number 5 here. They give us a picture of a roof. They tell us that it is 4 feet high. They tell us that this side of the roof is 6 feet long. And they want to know what is the angle there, right? What is the angle in that side of the roof there? Well, again, we have 2 sides, and they're asking us for an angle. And that is what? That is a trig question. So what did I do? First thing I did was I labeled my triangle. You should do that too. Here's my hypotenuse, right? If this is my angle, then this is the angle in question, and that's going to be the opposite side, and this is going to be the adjacent side. Well, let's take a look at this for a second. They gave me the opposite, and they also gave me the adjacent. Don't really need the hypotenuse here, do I? They're not asking me to find the hypotenuse. What they're asking me for here is for the angle. And they gave me the opposite, and they gave me the adjacent. They gave me the O, and they gave me the A. And if you look at so, ca, toa, the one that has O and A is going to be the tangent. So the tangent of this angle, which I've just named it X, the tangent of X, the tangent is going to be equal to the opposite over the adjacent. Opposite over adjacent. So the tangent of X is equal to the opposite side, which is 4, over the adjacent side, which is 6. So the tangent of this angle, whatever it is going to be 4 divided by 6, which is 0.66 repeating. Okay? Well, now that I have the decimal, remember, when I want to find the angle, we have to go in reverse, which means we have to use the inverse function. So when I have 0.66 in my calculator, right, we hit the shift button, we go to the inverse function, and I hit the inverse of 0.666 repeating, and that gives me 33.69. So this angle right here is going to be 33.69. If they ask me to round, well, they didn't ask me to round, Well, they give me an approximation here, and of course, between choices A to D, which is closer to